Let's look at equivalent fractions. Let's use a diagram to help represent an equivalent fraction. So let's look at something that's nice and simple. Let's look at a circle. Let's split that circle up into a half. So we have two parts, and one of those parts is shaded out of a total possibility of two. Now, if we wanted to find an equivalent fraction of a half, let's use the same circle with the same half shaded, but let's change the amount of parts it's split up into. So we now have 4 parts that it's split up into, so it's out of 4. So the denominator is 4. Our numerator, which is 2 parts shaded, becomes 2. So again, our equivalent fraction to a half becomes 2 over 4. We still only have half of our circle shaded. However, what changes is the number of parts it's split up into. This therefore changes the numerator value, or the value on top. So let's change the parts again on the bottom. So let's do a nice simple one. Let's change the parts to become out of 8. Let's go back to our diagram. Change this so we can have 8 equal parts. There we go. We have 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Now out of those 8, 4 are shaded. Therefore, we have 3 different equivalent fractions, one being in its simplest form, and the others here just being broken up into different parts. So if we followed this pattern, and we said that this was out of 16, broke those parts up into 16, we would have 8 parts that would be shaded. Here is another equivalent fraction. And that's the basics for equivalent fractions, guys.